game plan?
Yeah.
What if
Did
we-
everybody have, how are we doing for handouts? Doing okay? Okay. So I guess I'm just going to pick up where I left off. We need to finish this chapter on hurricanes. Got last what we were talking about. I really like this because we talked about tornadoes, and now we've talked about, or tornadoes including all severe weather, and now we're talking about hurricanes. And then we're going to talk about weather forecasting. We are going to begin that chapter today, and I brought my handouts, so that should all work out fine. So as far as monitoring hurricanes, remember these things are massive. So again, they are monitored as they cross the ocean basin, their ocean basin of choice. They can be upgraded, downgraded. Of course, they're upgraded. They pick up strength as they move over warm water. Okay, they can actually lose strength if they get too much wind shear. Okay, so how do we monitor them? Well, we can monitor them indirectly. These are two actually ways of monitoring using satellite imagery. There is a satellite. I hope this is all related to this class, isn't it? Because that's really annoying. Not related specifically to hurricanes, but there is this tropical rainfall measuring mission that actually goes around in the vicinity of the equator. And one of the things, since it's already there, it can do is to find regions of intense precipitation. So you can kind of see that here. I thought this is kind of cool. This is new to this edition. It's actually also a satellite. And it can, I think it's a satellite. It basically looks at the scattering of the ocean, what would be actually the water underneath the spiral rain bands, and it can get a sense for how it's being affected by the winds of the hurricane. So it looks, that is amazing. You're like, really? I like the name. It's called Scatterometer. It's like, really? Who thought of that? Somebody's 3-year-old, no. So this is back to Typhoon Haiyan. Remember that if the tropical cyclone is in certain parts of the world, in this case near Japan, they get different names. So Super Typhoon Haiyan. And actually, I was like, now why do I have this slide here? It probably could be that this is why we care. You know, they want to, we're going to talk about tropical cyclone warnings. I mean, they definitely need to give as much warning as possible to people to get out. Now, if you're on an island, what are you going to do? You know, but I don't know. So those were indirectly getting a sense for the hurricane using satellites. We can actually directly kind of get into the face of the hurricane by using those drop wind sounds that we looked at before. Those reconnaissance airplanes go over and they drop their little gizmo into this weather system. Doppler radar, remember we talked about Doppler radar when we talked about tornadoes. Doppler radar, we said you can get a sense of rotation coming towards you and away from you, the tornado vortex signature, so Doppler radar. Also can be used to get a sense for what's going on. And this is kind of neat. Related to Doppler radar or regular radar, along the coast they actually can kind of come together to share their Doppler radar information, send it through, as I understand it, a program to collectively then understand what that weather system is. So I think that's neat. Scientists play well together, most of the time. So this right here is looking at those scientists playing well together. This graph over here on the right, the red line is what the Vortrac would predict that the pressures would be. That's the red line. And the yellow dots or orange dots were the actual pressure. So whenever you can kind of get data, if you have a model, you should test your model. And actually, that's what's being done here. Okay. So another direct measurement would be those ocean buoys, sea surface temperatures. One of the things, oh, by the way, I enjoyed reading your proposed questions. It didn't make it to the test, but it was a good one. The idea of about 80 degrees Fahrenheit is kind of what you're looking for in ocean water temperatures. But I will tell you, the question I chose for extra credit for your test on Friday is one that I saw on several people's paper. You just like, I don't know which one it is. So, I know. So this is actually Hurricane Fran. We said day 1, day 2, left, right, okay? So you guys told me it was downgraded here. The isobars weren't quite so tight. The wind diminished as it left its source of energy. And the folks for here in North America that are watching both ocean basins for us are the National Hurricane Center, the NHC. I looked it up because I couldn't remember in Florida. I knew they were in Florida, but they're actually in Miami. So, National Hurricane Center. And clear back, oh, well, I guess it's coming up. Clear forward when we talk about how weather is predicted in the first place, you're going to see where the National Hurricane Center kind of fits in with regard to NOAA, the National Oceanic and Atmospheric Administration. So again, why do we care about the science of weather? Well, obviously people's safety. And on a test, if I ask you what was the deadliest hurricane, hopefully you're going to say the Galveston hurricane. All right. So the National Hurricane Center would put out, just like we get tornado watches and warnings, it's the same situation. If you have a hurricane watch, that means it's farther out and not quite sure how it's going to play out. A hurricane warning means it is more imminent and it is definitely playing out in probably a bad way. So one of my favorite terms with this hurricane thing is the forecast cone. Okay, here in a minute you're going to see what the forecast cone, basically which area might be affected. They call it a cone because it fans out because there's uncertainty. We just don't know which way the hurricane's necessarily going to go. But hurricane cone is the area of prediction. And I think on the documentary we saw the other day, they showed Mayor Nagel, I want to say, of New Orleans. And it becomes a challenge to know when you freak the public out, get the heck out of here, or when you just try to use what information you're going to be given with regard to the intensity of the storm. It's like, I think we'll be okay. So about the time you tell them to evacuate and there's no issue, what are they going to do next time when you tell them to evacuate? So I don't know. It's a tough one. But lead time is an issue. And here's that cone of, I think of cone of uncertainty. But this is that forecast cone. This was tropical storm. Remember, tropical storm is the stage right before tropical cyclone. Tropical storm Dean in 2007. So the H's would mean it would be hurricane status and then downgrade to storm status. Okay, but at this time, this is the best they could do. But can you kind of see, and we'll talk more about this in the next chapter when we talk about weather forecasting, see how it kind of gets wider and wider and wider. So it's like, yeah, that makes sense to me.
Is there any reason that it shifts from like a northeast?
That, I guess, would be kind of maybe the steering winds, the information they have about upper elevation winds. Yeah. And that would all be, and again, we're going to talk about this in chapter 13, you feed information to your computers and you have them, and then actually the weather analysis people kind of put their own personal spin onto it oftentimes. Whenever the computer spits out, they don't go, okay, computer. They go, all right. Well, based upon what I know, I think the computer said, and what I know, this is what the forecast is. So, all right. So let's take a look right quick at the assignment that will be due. We've kind of gotten in the habit of that. It's kind of fun. So this would be chapter 11. It looks like this. Now, when I handed back your homework, just be careful because there was a few of y'all not doing complete sentences like you should. And the other things, there was a few places where honestly, your answers, and I'm going to make some people paranoid, your answers are matching somebody else's answers pretty well. Now, I don't know whether that's because you're working together or that's because you're just getting from the same source, but just be careful. Okay, you need to make them unique. So, I grabbed this. It looks like all of these you have to use complete sentences, and yes, there are 6 questions, but they shouldn't be too bad. In the next chapter, there's only 3 questions. So the first one. Why might some people in parts of the world welcome hurricane season? What do you think? Why would you want a hurricane?
If they've had a dry spell, they need the rain.
I think that's a big one right there. If they've had a dry spell, they need the rain. Exactly. I like that one. So for 3, we actually have this figure here. It says, and the way this figure works is it's looking at, goodness, 150 years of tropical cyclones. It says, what do you see the most of? Let's see, what area has the most category 4 and 5 storms? So 4 and 5 is this orange and red. I might get out a map, but what's this area over here? What do you think? Anybody? Where's our geographers?
The Chinese
Yeah.
sea.
Yeah, I'm kind of thinking that too. So you figure it's over here. Yeah, here's Japan and here's China. So yeah, I think there. Why do hurricanes not form in the heart of the tropics? So why, and actually this is one of the criteria, why is this blank right here?
That's the
What's that?
intertropical zone.
Yeah, intertropical zone, and there's 3 criteria for a tropical cyclone. This is the second one. What does CF stands for? What's that? Needs to have rotation, exactly. Needs to have rotation. And you get rotate, if you're too close to the equator, there's no Coriolis force. And so that's actually what you're seeing there. No spin. Too close to the equator. And then the last one, I take a couple different answers for, but if you look, you kind of have an absence of storms in the South Atlantic and Eastern South Pacific. So South Atlantic, oh my goodness, so South Atlantic right here, and Eastern South Pacific. So these 2 regions right here. What's that? I'm thinking temperature too. I think they're temperature related. And I probably would just take that, you know, why is it cooler here? Well, you figure in the southern hemisphere, around a high, what direction does air go?
Counterclockwise.
It does go counterclockwise. So if I have a high here and I have a high here, counterclockwise, I'm going to go like this, and counterclockwise, I'm going to go like this. So actually, this one, you know, I definitely have the whole cold thing going on. This one, I'm not so sure, because it's actually kind of got, but maybe it's coming from, I don't know, but I think temperature for letter C. Okay, on to the next one. Next one looks like this. Oh, looks like I added something to it. So number 5.
We're skipping 4. Or?
Let's see.
It's not on this.
Yeah, it's 1, 3, 6. Oh, doesn't look like I have to do 1, 3, 5, 6. So number 5 says observational tools continue to improve. Potential loss for, but the potential life for hurricanes is likely growing. So in other words, we're getting better technology, but the potential for people losing their lives is increasing. Why would that be?
Because we have so many people
Mm-hmm.
living in those areas.
I'm with Kay. Because we have so many people who want their coastal, and historically it was like a whole transportation thing, but now I think, I don't know if it still is or not, but yeah, those are highly populated regions. I agree. And number 6, assume that it's late September in the year 2019. You have a hurricane category 5 is going to take this path, okay, and answer these questions. A says name the stages of development that this hurricane will go through, or must have gone through to become Hurricane Humberto, okay? So I, in blue, went ahead and reminded you the 4 stages, okay? So of course we have a tropical, I get my D's mixed up, so it's tropical disturbance, tropical depression, tropical storm, it gets named there, and hurricane. So those are the 4 stages. B, should you expect the city of Houston to have an issue with storm surge? How many people, find Houston, we have a problem. Houston is on the left of the eye. Left to right, yeah. It's on the left of the eye. How many people think that Houston will experience a storm surge? It will experience a storm surge, but how compared to the right? How many people think compared to the right it's going to be less intense? It is going to be less intense, yes. We talked about the fact that they're moving counterclockwise around the central low. On the right of the eye is going to get hammered. On the left of the eye, not so much. And so Houston actually is on the left of the eye. Let's see. C, what's the greatest threat to life if you live in Dallas, Fort Worth? What do you think the hurricane's going to do when it makes landfall? Weaken, yeah. So with that in mind, you're probably your winds are going to be less. So what are you going to be hammered by? The rain. I would say the rain. Your tornadoes will probably be weakened because of the source of energy. You and your tornadoes. Yeah, I'm thinking rain.
Why is it that Houston will experience the fastest winds?
It won't experience the fastest winds. Houston is on the left, and storm surge actually is weaker on the left of the eye and stronger on the right of the eye. Yep. Okay. Alrighty. So you recognize Hurricane Fran, and I did some, in my evening class, I kind of did some work. So yes, you're seeing what I did in my evening class. So focus on the first one. Which of these 2 days, looking at those two images, was the winds most intense? A or B? A, yep. And why? Isobars are closer. Yeah, we actually talked about that when we went through it. The next one, okay, says using these two maps, how far did the center of the hurricane move in 24 hours? And you can see I kind of went through a few things with my students there. But if you pick up the line of latitude, you pick up about 32 degrees latitude right there. There's the eye there. Over here, it's about 36 degrees latitude. Okay, so assuming that it's only kind of moving lines of latitude, it moved 4 degrees latitude. Okay, does that make sense? And then somebody in my night class looked up how many miles is each degree latitude. Looking about, what I got, 70? Yeah, about 70 miles. Somehow you got to get between A and B, you got to get how far that eye traveled. That's it. So you can do it different ways. You could use Google Maps probably to get the distance, but I kind of did it that way. So if you're looking at 280 miles, okay, that's the answer to the first one. The next one says, well, how fast is it moving then? And you can get rate if you divide distance, which is, what was it, 280, by time. That'll give you a rate. So, yep, that looks like the calculator for me. So if you take 280 divided by 24, that'll give you miles per hour. Okay? So that's kind of ballpark. If you go a different route to get distance, and that will be fine too. Okay. Now on to weather forecasting. Dun, dun, dun. I need to give you